Hello everyone, welcome to the YouTube channel Mission Net Physics Exam. And guys, in today's video, we are gonna discuss one of the very important type of question from the quantum mechanics. And these questions are gonna be from the previous year's GATE physics exam, but they will be equally important for the CSIR NET exam too. So in this video, I hope everything about these questions, all the concepts, all the steps you need to take, and everything will get clear to all of you. So we are soon gonna start the discussion about all these important questions which we are gonna cover in this video today. So I hope you all are ready for the discussion, and let's start the discussion now. Also guys, if you are new on this channel, that is Mission Net Physics Exam, then you can subscribe this channel by clicking on the subscribe button below this video, and also click on the bell icon to get the notifications for the new videos I'm gonna upload on this channel. Clear? And this video will be very much important for the CSIR NET Physics exam preparation, for the GATE Physics exam preparation, for all other similar PhD entrance exams too. Let's start the discussion about the questions now. I will explain all the steps involved in this question, and the other question is even there, so I will show you that one as well. The first question is from the GATE 2012 exam. The questions are from the perturbation theory part, but a little bit different, because in these questions we are gonna have the Hamiltonian given to us as well as the perturbation given to us in terms of metrics or in the form of metrics. Clear? So the first question, which is from GATE 2012 exam, the question is: consider a system in the unperturbed state described by the Hamiltonian, which is H naught, and that is equal to 1001, like in the matrix form it has been given. The system is subjected to a perturbation of the form. This is the perturbation we are having, okay, given in the question. So till now we are having two different metrics given to us. One is the unperturbed state, okay, corresponding to that, and the another one is corresponding to the perturbed state, okay. Two Hamiltonian we are having, or two different expressions we are gonna have here, okay. Next, here when they have mentioned H dash, okay, in this we are gonna have the delta present. So in this case they have mentioned the condition, that is where delta is very much less than 1, okay. Somewhere it can affect the expression too, the calculation steps too, so we should focus on these little things as well. Now next point, the energy eigenvalues of the perturbed system, okay, using the first order perturbation approximation R. So what we need to find? We need to find the energy eigenvalues of the perturbed system. Clear? Now I will let you know that what are the steps you will have to take to solve this question or any similar type of question. If you are someone who is already familiar with the steps you should take or how you can solve this type of question, you should start solving it. Just try to solve it initially, like you can start it basically, and I am even going to discuss it if somebody is here who is not familiar with the steps or who don't know like exactly what I should do in this question, what are the steps I should take. So I will let you know about that, don't worry. So basically guys, two different metrics have been given. One is unperturbed Hamiltonian, another one is perturbed one. Clear? And what you need to find? You need to find the energy eigenvalues of the perturbed system. Clear? Of the perturbed system. What you will have to do in this case, see, if there is something unperturbed, which means no disturbance in the system, there will be some energy corresponding to that system. Why I am gonna talk about energy? Because we all know H sign is equal to E sign. We all know about that. H sign is equal to E sign. Clear? What it shows? It shows that the eigenvalue of Hamiltonian is what? It is energy. Clear? What is that? That is gonna be energy. So that's why if this is unperturbed system, it will have some energy corresponding to the system. Clear? When we are gonna apply some external thing, you can say some external field, some external effect you are applying to that system, that is the perturbation. So after that there will be some changes, and it will depend what kind of perturbation we have applied, what kind of changes we are gonna do. It will be completely dependent on that part. So what we will do, we will firstly find the energy. Energy means the eigenvalue of the Hamiltonian, okay. corresponding to the unperturbed part, then we will find it corresponding to the perturbed part. Clear? And how to find the eigenvalues? We all know this is one of the most important concepts we are gonna have from the mathematical physics part, that to find the eigenvalues of any square matrix means in which the number of rows and number of columns both are equal, okay, like 2 rows and 2 columns, so it is a square matrix. So in this case, if we want to find what? We want to find the eigenvalue of any such type of matrix, then we are just going to do this thing, that is m minus lambda I, where m is that square matrix and this is equal to 0, okay, where we need to find the determinant of this complete matrix. So what is the unperturbed matrix here, or the Hamiltonian given to us? Because the eigenvalue of Hamiltonian is energy, and they are asking us to find the energy eigenvalue. So they have even given us some hint that okay, you need to work to find the eigenvalues. What we will do here, instead of h you will write, m, you will write h naught. So let's write it. It's gonna be 1 0 0 1 minus lambda, and I is the identity matrix here. So again 1 0 0 1. This is the identity matrix. Identity matrix means a matrix whose principal diagonal elements are gonna be 1, but the all other elements, okay, except the principal diagonal, they will be 0. Clear? Next point. And we take the identity matrix of the same order as we are gonna have the matrix given to us. Clear? Now, if we are gonna simplify it, what we will get? We are gonna get 1 minus lambda 0 0 and here 1 minus lambda, because this lambda will get multiplied with this term and this term, because all other terms in this matrix are 0. So that's how only from the principal diagonal part we have to subtract this lambda, okay, and we are gonna get this matrix. Now what will happen next? Now the next thing will be that you will have to simplify it and get the eigenvalues. So you will get 1 minus lambda whole square is equal to 0, which will give you lambda is equal to 1 comma 1, okay, because it was having the power 2, or it is a 2 by 2 order matrix. So 2 eigenvalues we will get. We are not getting any other value except 1. So we will say these are the degenerate eigenvalues, which means we are getting one particular eigenvalue more than once, okay, it is degenerate. So you got to know about the eigenvalues corresponding to the unperturbed matrix or the unperturbed Hamiltonian given to you in this question. In the same way, you need to find the eigenvalues for this perturbed Hamiltonian or the perturbation applied to the system. How you will get its eigenvalues? So again, same process, but the matrix has changed. That is delta, 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 all the elements we are going to have. So let's find its eigenvalues now. I'm just going to show you here that how to find the eigenvalues and all, so that if anybody is here, okay, who is not familiar with the steps, who don't know how to find the eigenvalues, so they will even be able to solve any such type of question after knowing about all the steps. Now the H dash, okay, that is the perturbed Hamiltonian. Clear? It is going to have the matrix elements as delta, 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 delta. What we need to do next? We just need to find its eigenvalues. So H dash minus lambda I is equal to 0. If you want to denote the eigenvalue with a different symbol, so you can even show it with lambda dash, okay, like already we have shown it with lambda here. So it's better to take a different symbol so that we will not have any kind of confusion. Next point, if I'm going to work on this eigenvalue part, so delta, delta, and I can directly write it now. I hope everybody will be familiar with the steps you need to take, as these are the similar steps here we have taken. Clear? Delta minus lambda whole square, like you are just simplifying the matrix, you are just finding its determinant right now. Next thing, after simplifying it in this way, it is what? It is a square minus b square form. So what you can do, you can write it as a minus b into a plus b, or a plus b into a minus b, okay. What is a here? And that is equal to 0. What is a here? Delta minus lambda. What is b here? Delta. So let's write it here. Delta minus lambda, delta minus lambda plus delta, okay. Delta minus lambda minus delta is equal to what? 0. Clear? And if you will have any doubt, you can mention it in the comments. I will just try to let you know what exactly will be the answer for that particular doubt you are gonna have, okay, so that it will get clear to you. Now after this, you just need to find the lambda values. So from this one, if you will equate it with 0, what you will get? Lambda will be equal to 0. And from the first part, what you will get after equating it with 0, you will get 2 delta. Okay, these two values you have got. And these are what? Lambda dash, lambda dash, lambda dash. We have changed its form just to consider it separate or the different one from the unperturbed part Hamiltonian, clear, or the eigenvalues. So this is how we are gonna have all these terms. Now you got the eigenvalues of the perturbed part or the perturbed Hamiltonian as 0 and 2 delta. And you got the eigenvalues of the unperturbed part as just 1. So what will be the final, okay, energy eigenvalues after considering the first order correction to the energy? So it is a part of the perturbation theory. What we need to do, we just need to add both the eigenvalues together. So 1 plus 0, 1. 1 plus 2 delta, it's gonna be 1 plus 2 delta itself. So what is your final answer you will have now? Let's check it out. 1 plus 1 plus 2 delta. I have just added both the values together. Even you can have a look at this. Same way it has been done here, but it was not in that much detail. So I have mentioned all the steps right now. So it's gonna be option A which will be correct, and how you are gonna get it, I have explained all the steps now. So I hope it will be easy for you to consider any such type of question, and you will easily be able to find the answer for any such type of question. If you will have any doubt anywhere, you can let me know about it. One more thing here, quickly you can have a look at the steps which have already been mentioned, so that like it will get more clear to you. Unperturbed Hamiltonian, then its eigenvalues, okay, you will find. Then what you need to do for the perturbed Hamiltonian, you will find the eigenvalues. They have been shown here, 0 and 2 delta we have got. How we have got them, I have shown here after calculation also. Now first order perturbation energy eigenvalue, just add both of them, which you have got for the unperturbed part and which you have got for the perturbed part. Clear? Add both the eigenvalues, you got the final answer. That is matching with option A, and that is the correct answer. I hope it will be clear to all of you now. And if there is any doubt what you need to do in that case, just mention it in the comments. We will try to consider those points as well. Now, the next question of similar type but little bit different. Clear? So let's have a look at this. It is going to be from GATE 2013 exam, that is GATE Physics 2013. The question is, to the given unperturbed Hamiltonian, this is the Hamiltonian given to us, and this is again unperturbed Hamiltonian, that means when there was no perturbation applied to the system. Next point, we add a small perturbation given by this. This again the matrix has been given, epsilon, and the matrix with the elements mentioned here, where epsilon is a small quantity. Clear? This much information has been given. Next point, the ground state eigenvector of the unperturbed Hamiltonian is. What they are asking here, this is going to be a little bit different question. So they are asking the ground state eigenvector of the unperturbed Hamiltonian. What will be the ground state? Ground state means minimum energy, okay, or the minimum value, whatever you are gonna get. So you need to find the ground state eigenvector, not the eigenvalue this time. They are asking for eigenvector of the unperturbed Hamiltonian. Clear? Now let's talk about it, that what are the steps you will have to take. The first thing will be, they have mentioned one thing which is very important for everyone to notice, that is unperturbed Hamiltonian, which means only unperturbed part you need to consider here. What you will do, corresponding to this unperturbed Hamiltonian, you will firstly find the eigenvalue. Clear? And once you will get the eigenvalues, because it is a 3 by 3 order matrix, you will get the 3 eigenvalues here. So what are the eigenvalues you are gonna get? I have mentioned them here. The process of finding the eigenvalues will be exactly same as we were doing in the last question. but 3 by 3 identity matrix you will have to consider. Okay, so that you will write H minus lambda I and the identity matrix of 3 by 3 order, 3 rows, 3 columns, and the principal diagonal elements you will write as 1 1 1 1, like that. Like, okay, just only these ones 1 1 1, the principal diagonal, and rest of the values will be 0 in the identity matrix, not in this one. You don't need to make any changes in this one. Now after that, what you need to do, you will find the eigenvalues. You will get 3 eigenvalues here, okay, which are 2, 3 and 7. There is no degenerate eigenvalue. These are non-degenerate because they have not been repeated, and we just got them once. Clear? Next point. Out of these 3, which one is the smaller one? That is going to be 2, which is the smallest eigenvalue we are going to have out of 2, 3 and 7. What we need to do now, why we were checking for the 2, that is the smallest one? Because here they have mentioned that we need to find the ground state eigenvector of the unperturbed Hamiltonian. Clear? So ground state means minimum value. That's how you have checked it once. And after that, what you need to do, you need to find the eigenvector corresponding to lambda is equal to 2. What you will get once you are going to work to find the eigenvector, if you are someone who don't know about the steps to find the eigenvector, one case I will explain here, then rest of the values I have even mentioned here. So that's how, if you will solve it later on for 7 and 3, because it will be required for the next part of the question, I will let you know where it is needed. But before that, let me just try to let you know about how to find the eigenvector, that process. Clear? See, if I'm going to talk about the eigenvalues that I have explained, what is the process? Because to reach to the final answer of the part 1 question, even we need to take these steps. Okay, so let's talk about it. What is the matrix? Let me just check. Okay. Just a second. Here it is. So firstly, let's work on finding its eigenvalue. Then let's work on finding its eigenvector. I will explain all the steps here. Let's say this is the unperturbed Hamiltonian as it is given in the question. So it is H, which is going to be what? The same matrix. So I'm going to start working to find the eigenvalue corresponding to this matrix. I will be what? I will be just 1 0 0 0 1 0 0 0 1. Okay, the principal diagonal elements will be only 1 in that case for I. When you will multiply it with lambda, only you will get lambda 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 here. So I am directly going to mention it now. I'm going to remove this one. So you are going to get it as 5 minus 2 2 0. This is the unperturbed Hamiltonian. 2 5 minus lambda. Why I have mentioned 2 here? It will be lambda only right now. Clear? And 0. Then 0 0 2 minus lambda. That's it. Equate it with 0. Find its determinant. To find the determinant, you will make the equation 5 minus lambda, this one as it is, or you can just find it corresponding to this value, that is 2 minus lambda. You will write as it is, then cross multiply these two values minus 4. Okay, that's how it will be more easy and less time taking for you. So just work on finding its determinant. Once you are going to work for that, then after simplification you will get the lambda values. The lambda values will be 2, 3 and 7. Because in the question they were asking for the ground state eigenvalue or the eigenvector in the first part. Let me just show you. They are asking for the ground state eigenvector. So in that case, what we will do, we will start working on finding the eigenvector now. What is the process to find the eigenvector? Let me just tell you about that. So basically, you will write it as it is, okay? And which one is the smallest eigenvalue? That is 2. Because we want to find it for the ground state, that's why we will firstly select the smaller value. Clear? The smallest one basically. Now at the places of lambda, just put 2. What you will get from here, it will be 5 minus 2, which is gonna be 3, then 2 as it is, then 0, then 2, 5 minus 2, 3, 0, then 0, 0, 2 minus 2 is equal to what? 0. And this is what I have mentioned, the same term, that is h minus lambda I. Into x if you will write here, and you will equate it with 0. And what is that x? That is gonna be the column matrix and having the elements x1, x2 and x3. Okay, and it is equal to what? 0. This is how, if you are going to write the matrix by multiplying it with one column matrix, you will now be able to find the eigenvector. Okay, what will be the next step? Multiply this row with this column. So you will get 3x1 plus 2x2 plus 0x3 is equal to 0. Similarly, make the second equation by multiplying this row with this column. You will get 2x1 plus 3x2 is equal to 0. If I'm going to talk about the last one, 0 into x3 is equal to 0. That means x3 can have any finite value. Even in that case, we will get it equal to 0 because already we are multiplying it with 0 and all the other terms too. Now, if you are going to see this thing, the equation 1 and equation 2, and you are going to simplify them with any of the methods. That means find the value of x1 from here, put it in the second equation, find the value of x2 from here, like from one of the equations, put it in the second one. Then you will find, after solving or simplifying it with any of the methods, okay, as you may have learned many methods to solve the equations of two variables, okay, and linear equations of two variables, clear? In the same way, you can apply any of the methods. You will find x1 and x2 both will be equal to what? 0. And okay, fine, we got it 0. That means there is no choice for x1 and x2. They will be 0. But what about x3? It can have any non-zero value. Also, you need to know one more thing, that when we talk about any eigenvector, then each and every eigenvector is going to be orthogonal or going to be normalized basically, not orthogonal. When we are talking about the eigenvector, simplifying it with itself, that means whatever value I'm going to consider here, just a second. Let's say I have taken 0, 0, x3. I don't know what is the x3 value. So when I will multiply it with itself, like its row matrix, okay, in this way. So with the row matrix, which means 0, 0, x3. You may be familiar with this concept of quantum mechanics. To check the normalization condition, this condition should get satisfied. So here, whatever wave function we write in this particular vector, we just take its complex conjugate. So in terms of matrix or in the form of matrix, we can't take its, like we can take its complex conjugate, but the point is here we are not having any imaginary term right now. And normally when we want to write it in this form, okay, in the changed form, we also make the changes, like the column matrix has been given, so we will make it the row matrix. So that's what I have done here. Now it should be equal to 1 for this vector to be normalized. Clear? And when I'm going to simplify it, I will get x3 square is equal to 1, which means x3 is equal to plus minus 1. But if you will check the options, okay, I'm even going to write the plus minus 1 both. Clear? If you will check the options now, because our main target is to match our answer with the options, and that too, it should be correct. Clear? So option C, you can see it's going to match, and minus 1 is not present anywhere at place of x3. So that is the right answer. This is how you can find it. But if I'm going to talk about the second part of this question, that is going to be, now this was the answer for the first part we have got. I hope each and every step will be clear to all of you. The second part is a pair of eigenvalues of the perturbed Hamiltonian using first order perturbation theory. Clear? It is going to be similar to the first question I have discussed. Clear? So firstly, you will find the eigenvalues of the unperturbed part, then perturbed part. Clear? And then get to know about what? Then get to know about the combination which is present in the options. If I'm going to show you some of the steps here, look at this. You have got the eigenvector corresponding to lambda is equal to 2, which is unperturbed part Hamiltonian. Clear? So this is the eigenvector you are going to get for 7. You will get this one. You will have to check the normalization condition too, as I have shown you. Then lambda 3 you will get in this form, okay, by taking all the steps. Now after that, what do you need to do? You need to simplify this part to get the first order correction. Now already the perturbed Hamiltonian has been given in the question, so you will put it here. That's going to be in terms of epsilon and then 1, 1, 1, whatever has been given. Just multiply epsilon in each and every term, each and every single term, like whatever terms are there, with all of them you will have to multiply the epsilon. Clear? So that's how you will write the perturbed part matrix. Then if I'm going to talk about lambda is equal to 7 part, so what you will do, this matrix, like this vector which you have got now, you will write it here. It's going to be 1 upon root 2, 1 upon root 2 and 0. Because this one I have told you that the column matrix form, you will have to change it or convert it into the row matrix. So that's what I have done here. In the same way, you are going to write it at this place. It is going to be 1 upon root 2, 1 upon root 2 and 0. Clear? And here the perturbed Hamiltonian, which one I will show you once so that nobody will make mistake. It's gonna be, just a second, it's gonna be this one. Okay, you can write epsilon, 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 minus epsilon, epsilon, minus epsilon and epsilon. So this is the Hamiltonian you will have to put here when you want to get the answer corresponding to the first order correction. Okay, and then just simplify one by one, step by step, and then what answer you will get from here. Let's say this is what you are gonna get. What you will get corresponding to lambda is equal to 7. I have even mentioned 2 epsilon. So what you need to do, add the 2 epsilon with 7 to get your final answer, like we have done in the first question as well. 7 plus 2 epsilon, 3. Corresponding to this, if you will check in the same way, you will get the value 0. Okay, because it is first order correction you are finding. Unperturbed part energy is already there. Then correction means something more you are gonna add. Clear? So you will have to add the value which you will get after simplifying it in the corresponding eigenvalue. Similarly, for lambda is equal to 2, you are gonna get epsilon. So add 2 plus epsilon, that is your final term. Okay, if you are gonna check 2 plus epsilon, 7 plus 2 epsilon, 3 plus 0, that is 3. So you will find that option C values are something like you are gonna get. Clear? So it's going to be 3 and 7 plus 2 epsilon. So they are matching exactly with the answer you are going to get. But rest of the combinations will not be correct. So only option C is correct and that is your right answer. I hope everything will be clear to all of you guys. I have tried to consider each and everything here. Whatever you need to know to solve each and every question. Okay, related to this type. I hope like even this part you all have read. Clear? Now let me just tell you about some of the important things that's gonna be related to the mock test. So on Unacademy, the free mock test for the GATE exam are gonna start. Even on the community tab, I have shared the link for enroll from which you can enroll to the test. Okay, you can even check the post there. Also guys, one more thing, I will try to just share the link in the description box as well. Another thing is, as you all know about the price hike part, I have already provided you the information in the previous videos. So it has been extended. That means price hike has not taken place yet. Clear? So if you are planning or if you want to take the Unacademy Plus subscription, even you can take the subscription right now. And whenever you are going to take the subscription, you can use and apply the referral code, that is Anjali Arora, as mentioned here. Whenever there will be some information related to the price hike, I will surely let you know about it. Okay, and the GATE exam mock test, which are the free mock tests, they are gonna start from 9th January, and the first mock test will start at 10 o'clock in the morning on 9th January. Clear? And this is for all the streams we are gonna have. One more thing, on the same day we will have our analysis session as well. The timing of the session will be 6 o'clock in the evening, and that is a special or the free live session. So even I keep on sharing the links for the free live sessions in the community tab. If you don't check that like community tab, please check it. Okay, you will get to know about many free live sessions. Even if you have missed any of the sessions, by clicking on the links you can even check out the recordings of the classes. Clear? And whenever you are going to take the Unacademy Plus subscription, because after taking the subscription you will be able to attend the live classes by all the top educators we are having on Unacademy Plus for your upcoming CSIR NET and GATE physics exam preparation. So you can use and apply the referral code, which is Anjali Arora, as mentioned here. By using and by applying this referral code, you will be able to get the 10% discount in the total Unacademy Plus subscription amount. After taking the Unacademy Plus subscription, with the guidance of all the top educators, you will be able to prepare very well for your upcoming exams. Clear? Also guys, for CSIR NET foundation tests are gonna start. Okay, or on Unacademy Plus even many new courses are gonna start time to time. Clear? And if you want to take the subscription right now. Even you can take the subscription right now, because after that you will even be able to cover up the recordings of the sessions which you have missed. Okay, and that's how you will even be able to ask about your doubts in the doubt clearing sessions, because in each and every course, after some number of sessions, for example 3 sessions, the 4th session in each and every course is gonna be the doubt clearing session. So that's how you will be able to clear your doubts. You can ask about your doubts if you are watching the previous recordings and you are not getting some point. That's how by asking it there you will be able to clear all your doubts. Clear? So guys, I hope now each and everything will be clear to all of you, and if you will have any doubt you can comment below this video. I will try to clear that point as well. Clear? So thank you so much everyone for joining this session, for watching this video till the end. And if you are new on this channel, then you can subscribe the channel by clicking on the subscribe button below this video, and also click on the bell icon. Guys, you can even share the video with all your friends, those who are preparing for the CSIR NET exam or for the GATE exam, as well as for any other PhD entrance exam. This video will be helpful for all of them. Even you can tell me in the comments that on which topics you want me to provide you the videos for your upcoming exams, or what are the topics you find difficult. We will try to just consider that topic soon as well. Clear? Thank you so much everyone for watching this video till the end. Thank you.